that was a very wonderful afternoon of talks. I learned a lot. I mean, I will start with Harald, because he was left, unable to answer many of the questions that we were all aching to ask him. So, Harald, you worked on, as you said, the relationship between legal entity identifiers and smart contracts is all about precisely sort of identifying agents involved, various clauses in contracts, and so on. Your data set. You first look at, let's say, the Airbnb data set. But what I really want to get to understand is the extent to which entirely smart contracts, in other words, self-executing online contracts, exist in the economy. And the Airbnb is where you, as a researcher, take the data and then analyze it. Whereas pure self-executing smart contracts that exist entirely online has no counterparty, existence in the analog world. What percentage of all contracts now are pure smart contracts, for one? That's the first aspect of my question. As opposed to, the analysis that you're doing on existing contracts that could also have an analog avatar. Harald, are you there?
Yes. Should I answer that? Should I take your question now? Yeah. Actually, it's been a while that I have not looked into the volume turnover, any metrics on the main platforms that I think Ethereum is still the most popular platform for hosting smart contracts. I would answer in two ways. We see that we are in a way maturing into two kind of use cases for smart contracts. One that is the classical one that with the ERC standard that Ethereum has launched, but that can be implemented on other blockchains, of course, as well. I mean, there's no reason why you could not launch a private currency on Bitcoin. In addition, Bitcoin being itself money, but you see what I mean. So, I mean, there's the one smart contract that you mentioned that basically lives only in cyberspace, and that is only also efficient when it is purely connecting to addresses.
Absolutely. Yeah.
This is the first type. But what we see more and more, and that is maybe for supply chain management and risk management, the more interesting type, is a perversion of this one, where you strip away the money item, the monetary function of the smart contract, and you may even strip away what was initially a core defining feature of automating payments. Yeah, because the payment is in terms of what you do, it is just sending information from one address to another, right? It is different from. I mean, cash is not a meaningful concept in it. It's just changing the value of one address and another address. This is all you do. So instead of a payment, you can just send any kind of information. And the smart contract, basically, the second type of use case is what we see more and more in supply chain management and contract management, like asset liability management, where you're not interested in a transfer, in a payment that changes the balances of two addresses in two wallets, but you just want to basically exchange other kinds of assets, the assets being some relevant information. Or simply you change the status of two addresses, but it's not corresponding to a cash or a monetary balance, but to something else, And there are numerous use cases in the context of compliance, of regulatory or supervisory reporting, where the payment function that was originally the value proposition of the smart contract is not the most interesting one, but rather to confirm to a third party to any third party, so to an principal unlimited number of third parties, that a certain information was provided at a particular point in time, and to confirm this with mathematical, approximate certainty to a very high degree. So I think these two universes have been diverging for a while, and I'm personally not very upbeat on the currency use case. I think in the long term, the analysis carried out in the early days by people like I have a black hole now, Garrett at Cambridge, that Bitcoin will have also in the medium run a value for jurisdictions with poor governance, weak governments, and poor rule of law, and these kinds of things. I think this is correct. But in the medium term, in European US, I mean, I don't want to speculate on the US, but in Europe, the Bitcoin has no future, clearly, because the digital euro is on the doorstep, and the digital euro is the end of Bitcoin for European markets. I'm sorry to say that, but I've been saying this.
Is this insider information? How soon is this going to happen?
No, it's not insider. It's all public domain. You can just Google ECB digital euro. You see this is progressing very fast.
But what do we talk about? What time horizon have we talked about, Harald? End of this year? Next year?
We talk about 5 years.
5 years.
We're talking about 5 years. So in those 5 years, of course, you can see a wild gyration still in the cryptocurrency market, and they will continue to exist because there are a majority of jurisdictions on this planet that are actually very poorly governed. I mean, it's the majority of countries on this planet that have very poor governance, very poor rule of law, where people have strong economic incentives to hide their assets, to transfer their belongings across borders without the government being knowing about it. So there's still a medium term, a very bright future for cryptocurrencies. But I'm working in a policy institution in the European Union. In the European Union, it is a dead end.
There are two very exciting people raise their hands.
But the supply chain use case, which does not involve payments, so you can have a supply chain management using smart contracts while keeping all your payments in the standard banking network. It is highly effective. It adds a lot of controllability, manageability, and transparency, and it can prevent you from paying fines for honest errors, because the compliance and reporting environment has become so complex that you pay mostly fines for honest errors. You're not even paying fines for
actually, this
errors
is a very good
to
point,
commit,
that
you pay fines for honest
separate
errors,
out
and
the
that
payment system, the payment execution from the execution of the conditions of the contract. I think that's a very good point. I'll take Anandi's because he raised his hand first, and then Anko.
Yeah, Harald, it's a news to me, first of all. I'm also, very interesting point to begin with. But this was not part of your presentation, I know. But given that you made this comment that Bitcoin will be essentially replaced by this, but that also means that the nature of monetary policy would also have to change. Because the usual way of setting up the borrowing rate and the lending rate by the central bank will not probably work. So can you shed some light on?
Actually, my question is very much related.
Actually, Anandi, can I just point out that that's not directly related to, monetary policy is not directly related to our themes.
I just got very curious as to.
My question is more. My question is more on the governance.
If you had real drinks around, we could hive that off then. Uncle, what's your question?
My question is more on the governance structure of the digital euro that you are talking about. And do you see that the governance structure is very, how different is it from euro, and how different is it from Bitcoins?
It would be, it would be. It would be not different at all from euro, because the digital euro.
And that makes it very different from Bitcoins, right?
Exactly, very different from Bitcoin, but actually there could be some commonality. I can explain. To euro, there is zero difference in governance by definition, because the digital euro will be an application. Yeah, it will be a software application. It will not replace the euro. So the monetary policy will be defined by fiat money, the euro, and basically you get an application that will have a small positive cost for using it. And I think there is an economist at the Bank of England who was I think
Michael Kumhoff.
Yeah, of course, Michael would have worked a lot on this concept. Why actually a positive user cost of the digital currency is really also a very interesting beneficial concept, actually. So it introduces a price element that has very interesting features, actually, also from a monetary policy perspective. So I can highly recommend Michael Kumhoff's work on this. But there could be some things that we can learn from Bitcoin, and that is the way they use. They allow basically every user that is ready to invest into studying the protocol and looking for glitches and weaknesses. So I think the open source philosophy, the philosophy of having an open-ended user community that can contribute to improving the protocol of the app, if you want, I think this is something that we should probably adopt from the private cryptocurrency space. Very much like in telecoms, they tried closed models and they had to go back to open contribution models because they were just producing better results, more stable applications, more stable systems.
Okay, can I move to Niki's talk today? So, Niki, you're concerned about various aspects of the legal entity identifiers, but I also know that you work on innovation and recombination. It's another theme in all digital systems. One of the great advantages of a digital world is that you can recombine things. It's easy to do that with software. It's very hard to do with analog components. So do you want to just throw light, because I'm widening the scope of, because I know your backgrounds and where you're coming from and how you contribute to this theme of the digital economy and so on. Do you want to throw some light on innovation and recombinations? Niki.
Apologies, the dreaded mute button. Yes, of course. And I'm probably going to go back to something I think Harald said about Schumpeter, and recombination. So we were, it's interesting. I think one of the interesting things about the sort of digital economy, if we use that sort of catch-all term, is that, how digitization does allow this kind of recombinability and generativity as well. And while I was probably still at Warwick before I moved to Leicester, we were working with a couple of my colleagues there on kind of trying to understand value, the value of digital of digital innovation in terms of recombinations of digital resources that could be sort of combined and recombined, and how that sort of changes our view of value from something which is sort of like a number to something which is more, like a field or a space. I think in that initial paper, we called it open value space or something like that, which is sort of very much then sort of changes your perspective into sort of viewing how you sort of channel value paths through various combinations or recombinations of these digital resources, which of course can include, human as well as kind of technological elements there as well, you could argue that cognition is a type of resource that could be combined in these kind of in these assemblages. So it was kind of quite a theoretical paper, but then subsequently in the project that I'm working on at the moment with the people at Cork that you were a reviewer for, we were looking at sort of trying to sort of use that in a more kind of concrete, more kind of use kind of case situation, looking at, say, the value co-creation between users and developers, say, of services like Revolut, and looking particularly at, say, forums like app store comments that people leave, and sort of trying to sort of see how the apps kind of evolve, in some way related to the way that their users kind of comment on these apps. So I don't know if that sort of really helps very much, but we're sort of trying to build a kind of more concrete, kind of empirically based sort of view of this kind of idea of recombination and generativity that we see in digital innovation, to sort of try and actually now migrate to analyzing actual cases. And we've got a paper in review now, a second round with MISQ, which is exactly on the case that we talked to you about. So I think it's a very nice way, because you're sort of seeing how something which probably was very theoretical even in the Schumpeter view, actually in the digital economy is something that becomes quite concrete. And I think the challenge to us is to try and see what conceptual tools we need, whether they're kind of quantitative or qualitative or a combination, to kind of actually try and understand this kind of digital environment in this way, through this kind of combination, recombination. And the thing that sort of made us go for that view was this sort of, seeing how users can actually combine and recombine kind of digital resources themselves, but also, increasingly, smart contracts is one subset, but, digital agents, can actually be combining digital resources to provide, maybe sort of new services that are sort of almost sort of robo-designed. So this is the sort of reason why we think that's a long-term kind of interesting area to kind of investigate. So this was sort of work in information systems, but I'm sure there's a lot of crossover with a lot of the work other people are doing. And, even with the, just to go to the last paper we had about the business news, we're actually sort of developing from the initial paper. Now we're sort of looking at sentiment analysis of those comments, but in a kind of machine learning kind of way, and seeing if we can actually sort of find some kind of relationship between the sentiment that we pick up in the user comments and kind of tendencies to download or uninstall kind of particular apps and so on. So it's a very kind of interesting area, I think. I don't know if that answers your question. Yeah.
Yes, thanks, Nikki. That'll open up the discussion now with Sudip. Sudip, let me put it to you about quantum computing, or what I understand. I think it's on a pragmatic level, it is going to happen, because what all the superpositioning helps people do is, to my mind, it is like a sort of Uber introducing parallel computing in a very Uber way, meaning to say the superpositioning, whereas we would do things sequentially or in a less parallel way, you can conceive of multiple scenarios at one and the same time, right? You gave the example of somebody having an apple and having a banana. It obviously cannot happen at the same time in real time, but offline in simulations and in calculations, I think this is going to be the case. But there is a very interesting issue to do with blockchain and the double spend problem. As I keep telling students, the physicality obviously obviates the double spend problem with cash. Because if I give you $1, then it's no longer with me, and it cannot be in two places at the same time. So in one sense, the entire problem of double spend is obviating or trying to get around this thing that a particle can be in the same in two places at the same time. But on the other hand, in the offline environment, so we've got this thing that in real time and on online environments, these things cannot happen. It shouldn't happen in proper financial accounting. But offline, the pragmatic aspect of superposition in multiple scenarios, holding at one at the same time, is something that can happen and is going to be the future of computing, because it speeds up this parallel process, in a sort of very intense way. So I'd like your, comments on that.
Yeah, thank you very much. Yes, I think that a lot of exciting stuff is happening in, trying to adapt to quantum computation. And as far as I see, that two aspects. One is certainly, a more pragmatic mathematical modeling that, we are doing. It's really not going into really using the resources, for example, entanglement and superposition, how to use them for kind of future financial technologies. That would be really the second revolution, one can say, in that area. For example, recently, as I was just mentioning, there is a very interesting sub-branch of game theory which has come up, which is quantum games. Now, quantum games is not simply like mathematical modeling. One is certainly there, when you observe real people play game and then try to describe their behavior with the help of this framework. But the other one is like when real people are basically sharing certain kind of circuits or sharing certain kind of physical systems. And within the physical system, there can be certain interesting features ingrained, like superposition, as you have rightly mentioned, or entanglement. And it has been shown.
Sorry, can you tell us what's the difference between the two?
Okay. One is superposition is certainly the linear combinations of, say, zeros and ones or yes and no's, different works, one can say. And when you are still not measuring a particular state, the state is in a linear superposition of possibilities. So that is the superposition principle would say. But entanglement is entirely different. Entanglement, though it kind of takes its power from superposition principle, but entanglement would actually mean, say, for example, that two agents, Alice and Bob, and they are spatially separated. It may be even light years, but they are sharing some kind of a system which had generated at the same origin. And then the system has been separated for some time. Now, what happens is that if you can really design that system carefully, then whatever update you do on Alice's end, that is immediately going to inform Bob or inform Alice about Bob's state. So that is like the entanglement. And now entanglement,
is that a hypothetical system or?
No, it has been shown. Now entanglement is very much like talked about, and it is used as a resource.
And when you say at the same time instantaneously, are you expecting some sort of a gap of certain amount of time for light to travel from one system to the other?
Yes. Actually, you see that we have to be careful here. One is certainly the superluminal travel, which is not allowed. But certainly you can use entanglement as a resource to increase the computation power of your system. That can be done without breaking the speed limit of light. That is there, because that is what is known as to be no signaling condition in physics. But very interestingly, these technologies are really coming up, and people are working on these technologies for financial, markets and so on. So it is quite promising to see that maybe. And also another thing I just forgot to mention, that in game theory, there is another interesting concept which has come up, which is quantum Bayesian networks. So one was Bayesian networks, where you are trying to calculate the conditional probabilities at each and every node of interaction. But now, if you think that human agents or even machine learning, etc., they use a different kind of framework for updation of beliefs and probabilities, then quantum Bayesian networks gives more accurate results. And there's a huge amount of research which is happening in that direction also.
There's one more question, Sudip, that I want to ask you, and that is to do with, the point that you made about agreeing to disagree in common knowledge models, right? So there is another solution to that problem. I mean, the idea that it's a sort of one I've suggested, that if the fixed point, when you have a contrarian agent, right, somebody's putting a negation on some outcome that can be predicted, and then then you try to find the fixed point of that negation, that becomes non-computable, right? So of course, since that's non-computable, you have to agree to disagree at those points when you have these contrarian agents in the system. So the fact that you're saying, so that could be another explanation over and above the one that you suggested.
Yeah, that's true. As far as I have seen, that there are quite a few research that has happened in that direction. One particular research that I was pointing to was done by Andrei Krenikov, who is like one of the most noted mathematician in this area. And he was the first one to show that if agents do have this quantum-like framework for belief updating, then what would happen is that there would have been more general solution to Aumann's theorem. Or in other words, in most general cases, if even the priors are known to everyone and posteriors are a common knowledge, the probabilities, even then people might will be happy to disagree. There will be like chances where people may disagree. But that doesn't mean that the classical solutions will not occur. They will also occur, but they will all occur as like more special cases of a general solution. But I found that is an interesting direction, because you see that in economics, for example, costly signaling literature is like a very central piece. And in costly signaling literature, there may be some very interesting connection with the modifications of Aumann's theorem in that way.
Now, can I turn to one of Dan's other research interests, which is also relevant to our...
Sheri, there is a question in the Q&A from one of the attendees.
Okay, let me have a look at it.
Yeah, that is for Sudip, I guess.
So it's from Alex Anthony. So do you want to read it, Sudip, or shall I just quickly read? What's the motivation behind the use of quantum-like modeling, considering that there isn't much of an argument to be made towards human brain being quantum mechanical in nature? Timescales under consideration are milliseconds, sizes under consideration are millimeters or micrometers. Temperature is room temperature. The energy scales are too small to consider quantum mechanics. Okay.
I'm fully aware of that. You see that that is what we always refer to, that one is like this quantum physical brain, which is not our research area. So that is certainly not what we are saying. Sir Roger Penrose and Stuart Hammer of our core model.
Yeah, he talks about the superpositioning, that you can consider many things, contradictory things at the same time.
So that we are not suggesting at all. So our point of view is more into the mathematical modeling of decision making. And also then certainly while designing games, then you can harness the real power of entanglement and superposition. So that is like designing the game. So in these two areas, we can contribute.
Okay, so thanks, Alex. He's one of my students, actually. He's got a first degree in physics and a second degree in physics, and now he's doing data science at Essex. So let me move to Dan. Dan, I know, this area that you say, the role of algos and systemic stability, right? The jury is still out on that, isn't it? Do algorithmic trading and so on stabilize the system? Would you want to say some more about that?
Yes, I can do. Yes, as you say, I think the jury's still out on it. I think there's, like many questions of trading behavior and particularly around endogeneity, there's understanding the effect of algorithmic traders on market stability is very difficult. I think perhaps the dominant position at the moment is that during good times, they're beneficial. They improve liquidity, they reduce spreads, they reduce costs in general. However, during crises or crashes, the opposite unfortunately happens. They're the first people out of the market, and what did look to be a liquid market suddenly isn't and evaporates. I think this is particularly interesting as well when you have algo traders who are trading multiple assets. So there's been some very interesting work over the last decade looking at how pairs trading and similar strategies can result in crashes in one market spreading to other markets due to essentially liquidity spillovers. The presence of algorithmic traders potentially makes that both, well, pairs trading is a very attractive strategy for algorithmic traders. There's all sorts of bits of work, fascinating bits of work looking at how changing communications technology, changing lengths of wire between Chicago and New York, for instance, are affecting the algorithmic trading, high frequency trading between them. But yeah, so the rise of algorithmic traders has really seen an increase in pairs trading between different stocks. And that is a real mechanism for the spread of liquidity crisis. I have some very recent work looking at that, which mirrors some findings in the banking literature that suggests that high frequency traders doing that type of work, who are effectively connecting together different assets, actually provide stability a lot of the time, that they allow shocks to diffuse relatively harmlessly. However, again, during severe events, the opposite can be true, that they actually provide a new mechanism for shocks to spread between different asset classes and exacerbate the crisis.
Okay, I think I've done my job. If you guys want to ask one another questions, spontaneously, please leave of one another. Please feel free to do
There's
that.
a question lined up in the chat box. Yeah,
Ankur, do you want to say it? Yeah.
Let me just have a.
But maybe Harald can go ahead. Harald wanted to add something. So
I had a question to Daniel and a question also to just an observation when I listened to Ankur and Sudip's dialogue on fuzzy logic. I remember reading Sadeh's original contribution in '95 in a library, and I thought it was really interesting. But I can kind of grasp that the formulation that you propose, Sudip, is quite matching very many real world use cases, because the continuous transition function of fuzzy logic it works super well with electrical motors, which can closely match this continuous change from 0 to 1, but human decision making is very rarely matching a continuous transition function. So we have much more use cases where we have very discrete, and I also see why Bayesian logic is really coming into its own with the addition of the quantum. I never liked it a lot, Bayesian, before quantum, but it seems to make sense. Like cryptography makes much more sense when we get to quantum cryptography. So I think it's like a missing piece that we were looking for quite a while, and that's super interesting. But I wanted to ask a question to Daniel that has been haunting me for forever since I was working on financial markets. So for quite some years, I never saw how. I can find many good reasons why you want to have dark pools and other informal markets, non-lit markets, no matter who you call them, adding flexibility to existing markets and regulated markets. I think there are many good examples in other parts of the economy. But what I never understood about the financial market efficiency argument is on the vast majority of companies, there is almost no news for the whole year. Okay. There are a few companies that generate a lot of news, and the vast majority of companies has no news outside the financial statement. Yeah, mm-hmm. and when what can you learn when there is no news? And the scarcity of news is really a compelling feature of markets, and the extreme distribution of news. So a few players are basically concentrating 80% of the news items, and the 20% is for all the rest. And that always escaped me. Apart from the fact that the work of Andrew at Imperial College, I have trouble with family names today, showed that what really crashes is the link between the mathematical and the physical implementation in the computer. It's not so much the algorithm that is a problem, but when the algorithm needs to be implemented by a machine, and in the machine you have waiting times, you have discrete jumps, whereas the algorithm works on a fiction of continuous functions, which in a machine implementation do not exist. There's no such thing as a continuous implementation in a physical machine.
Can Daniel answer that?
But maybe Daniel has an intuition that that helps me with that struggle.
Yeah, no, I think it's a really interesting question. I think it's a set of connected questions. Yes, you're right. In many cases, the actual news originating from firms is very minimal. I think there is more news in the broader macroeconomic environment. Whilst the individual firm might not be changing, the environment is. I think, from my point of view, a lot of it though is liquidity trading. Individuals trading off the actions of other individuals. But still, I think there's a very valid argument, and this applies to HT in general, is who's really benefiting from price efficiency, if we call it that, at the microsecond level. And it's not clear that there's an economic benefit for that. With regards to bringing in algorithmic trading in this, I think that's a fascinating question. I wrote a paper a couple of years ago looking at the trade-off between algorithmic speed and sophistication. Essentially, if you look at the economics or the financial economic literature, the theoretical side of it assumes essentially perfect rationality of algorithmic traders. And as Sheri and others have shown, that a lot of the decisions that these traders are making are in some of the hardest computational classes. So trying to, making assumptions around algorithmic traders being perfectly rational at the microsecond level is, ridiculous in a really meaningful sense. You speak to the people implementing some of these algorithms and they talk about 10, 15 instructions, one conditional instruction, very, very, very simple. Literally instructions cost money. It takes a very small but positive amount of time to execute each instruction. So each instruction you can shave off, speeds up your algorithm and speeds up the potential execution speed. So I have a paper from, literally a year or two now, looking at that trade-off. Where should you be in the spectrum of speed versus sophistication? My findings are, yes, there is a trade-off. There's multiple equilibria from an economic point of view. But you do start to lose, you lose opportunities, you lose money as you get faster and faster, but you do get to be the first to trading opportunities. The next step I'd like to take on that journey of understanding that, I think, is getting to the one that you are hinting at, that as well as trying to understand the decisions made by algorithms, it'd be really good, behavioral finance has taught us a lot about how individuals make investment decisions, how they trade off risk versus return versus, things like anchoring effects and so on. How do programmers who are implementing algorithmic trading strategies, how do those same sorts of trade-offs affect their programming style? Do the behavioral biases of programmers then filter through to the algorithms they're writing? Does the programmer's understanding of discrete versus continuous, theory versus practice, how does that then come through? To my knowledge, there's very little work looking at that yet. I think it's a fascinating topic, but it's not yet being fully addressed.
I think we should. I think Niki's got his hand up.
Yeah, just a quick riff of Daniel's answer about liquidity trading. I mean, this is an area that's sort of quite it's of interest to me. This sort of social studies of finance area where you're looking at the sell side and how much work the sell side does to kind of fill in those news gaps that say the business news isn't covering, and sort of generate liquidity trading, because that's how they, the sell side makes commissions, by encouraging people to trade even if there isn't that much news. So in a sense, the other side of the sort of actual, the business news that's out there is also the sort of, the news that is within the sort of markets, so it's interesting to sort of keep an eye also on the sort of market macro structure a little bit as well as the sort of news element of the information going into the trading. So yeah, just a quick sort of add-on that sort of came to my mind as Dan was talking.
Interestingly, I would just like to add one particular thing to it about the value of business news for trading. So we did a Granger's causality test on does news impact the sentiments or the sentiments impact the news? How exactly does it work? And of course, the response that we got was that it works both ways. So the Granger's causality turned out to be positive both the ways. And that kind of explains the analysis that we were working on when we were taking just those companies into account and trying to take into account their sentiments and predict the stock price and generate useful trades out of it. It turned out to not lead to anything positive. So there were companies that were generating maybe one news item in 2 weeks, and then there were companies that were generating hundreds of news items in a particular day. When we were talking about companies generating hundreds of news items in a particular day, it was much easier to account for the sentiment because a lot of noise got cancelled and we were getting very good measures of the sentiment, and then you were placing the trades. Whereas for the companies that from where, in the context of which there was just one news item coming out after 2 weeks or so, it was not possible to create a tradable strategy, primarily because maybe the news came out much later and that information was already there in the market. And just because it's such an unknown company that people who were kind of closely following the company, they had that information. And much later, one of the reporters found out that, okay, this is something I need to report. And then the news item came out in the media. So it just doesn't have any tradable value. So these are some of the outcomes that we got out of this massive study, which lasted for almost 3 years or so while we were analyzing data from 20 years and so on. Very quickly to take up this question from Amir Singh as well. So I'd just like to state that when it comes to understanding the news itself from the machine learning point of view, that is already a solved problem. As I just showed you that figuring out the sentiments and the accuracies and stuff, we are working at a very good accuracy of 95%. So in case there is one particular statement given to you and you want to understand what is contained in that statement, is it positive, is it negative, which company is it talking about, which sector it is talking about, that is very much, I would say, a solved problem. Now, the next challenging problem, of course, that we are facing is that how do we differentiate from reliable sources and fake sources, and that is where most of the research is identifying fake news, identifying fake speeches, identifying fake people, fake videos, and stuff like that. And that definitely remains a challenge.
Thank you very much. Unless there are very pressing questions, I have to say this is exactly the sort of discussions we were hoping to stimulate. You know, the original format of this conference, we were all going to be in a single room and sort of, but I think you know, we have communicated and formed links and sort of got into one another's space and heads. And I think that is exactly what we want. And hopefully this communication will continue online. You know, we can have further smaller groups that we can have specific areas that we can investigate in, let's say, half an hour video and so on and so forth, right? So come up with the ideas because we've got the funds. It's the only thing that we're spending money on. We're not spending it on booze. We're not spending on travel or on, accommodation, things like that. So we can continue with these conversations in that way. So all you got to do is drop me a line, drop me and Anandya a line. We'll try and, accommodate that. Twimbit is there to help us create podcasts, blogs, little further discussions. You know, I can come up with more specific things that, let's say, I put to Sudip, but then, he answers it. Or Sudip himself puts further blogs on his little thumbnail. You notice that all of us have little thumbnail boxes on our AI Digicom website into which we can funnel not just the talks that we've had, the YouTube videos and all that. We can put other stuff into it. So we've got just one more thing. I think we've exhausted people's capability of sitting in one place for, 4 hours, 5 hours.
Sheri,
and it's pretty late in India.
if you admit, I would have a last curveball to participants going into tomorrow's discussion on AI. And quite philosophical topics, and it's another of these questions. So I was not very successful maybe in presenting that in our study we had confirmation that we may have the digital economy may have showing us actually the end of this trend to commodification of everything. So we had a secular trend that everything becomes a commodity. I think digital goes in reverse, because values get their value from their being part of a particular network, and if you try to rip them out of their concept, you destroy much of the value. You either buy a whole team or not, but you cannot buy an individual member and get the value of the team. It's not possible. And actually, I think the human being in the long term wants to create the economy and the universe in his picture. This is not a religious statement. I really think we try to create our environment in a way that relates to us, because from psychology, I think it is long known that if you rip things out of context, people go crazy. People need to relate to their environment in a way that they understand, or they think they understand, because we tell our stories.
Harald,
I wanted to give this to going into tomorrow when we talk about AI. And
you will notice that
is the
a lot
digital
of the
economy not a
tomorrow,
more human economy in this sense, where this everything can become a commodity was actually not really relating to us. That's not us. That's not how we function as human beings and in society. So as a question to going into tomorrow.
No, I think the point that you made about how price is not everything, and secondly that profit maximization may not be, Schumpeter pointed out, we don't really know all those bits, and what we know is perhaps only our costs. So the duality doesn't always hold. That's a very good point you made. And so, the session tomorrow afternoon would be just as intense, because we brought some very big brains to talk about this. Embodied cognition is very high up on Carl Fuston's list of things, and active inference and so on. So it'll all come up again tomorrow. So join us again tomorrow. And I think we have completely lost a lot of our external audience, because it's really quite a long session, quite intense one. So it only remains for me to thank all of you. That was wonderful. I really, really think we fulfilled many of our ambitions of banging heads together, and hope to see you tomorrow. We have a session starting at 9:30 on the application of fintech and so on to overcome issues such as financial exclusion, sustainable development, and so on. And so I hope to see you there then, if not later in the afternoon. Thank you very much again, and goodbye for now.